Hello, welcome back. We're going to take a look at structures, classes, and objects today. To get into object-oriented programming, which is really the core of this course, we need to start from the beginning, which is refreshing ourselves on what are structures, what are classes, what are objects. And the examples I put together here are a series of exercises that build on top of each other to show us all the things that we can do with classes and structures and so on. So let's dig right in. Starting with exercise 1, we're going to make an animal class. Think about what sorts of attributes and methods an animal might have. Include them in our code, and we're going to instantiate two different animals inside of our main method. So let's begin. We'll make a new file. Example 1. No, that's okay. Here we go. Okay, so we make an animal class. Think about some attributes and methods. Include them and instantiate them. So this is pretty open, but it's important to at least keep in mind what sorts of formatting we need to use in order to set up our animal class. So to set up an animal class, we need to say class animal. So now we have an animal class. I'm going to add a semicolon after this, and we're going to set some public attributes and methods so that we can actually access them in our main method. What might an animal have? Well, it might have a string that represents its species. It might also have a string that represents its name. And maybe it will have an age. Sure, why not? Now, it also might have some methods. So let's say that we might need a method to make a sound. So let's say void make noise. We'll have a, what else? Maybe eat. So void eat, and this will take a food as a parameter, for example. And now I want to perhaps write the code for these functions. So maybe make noise will keep really simple. And make noise is just going to be output rar. Pretty short. Maybe eat is more involved, and so for that we can actually write our eat function outside of our animal class. We can write it down below. It is a void function. It belongs to the animal class, and it's called eat. Since I'm not writing it inside of my class, I need to write it like this so that I confirm to C++ that it's a void type, it belongs to animal, and it's called eat. The parameter is a food, and here we're going to say animal is eating food. Yum. Why not? We can obviously add on to this, but this is enough to do what we need to. And in fact, we may also want to make it so it's not just animal. We want it to make sure it's this animal. So instead of animal is eating, let's do this name is eating. So that way, if I have an animal, I can say which animal is eating. Let's try this out by making some animals. So in my main function, I have my animal dog is an animal. So we'll say animal dog, and we can say dog.name is Cheeto, that's my dog. Dog.age is 3. We won't need to set the species because we're not really using it right now, but that's okay. And then let's also do cat. And the cat's name is Cheddar. And the cat's age is 13. Now, if we want to call our methods, we can do dog.makeNoise, dog.eat salmon, cat.eat tuna, and see what this does. Let's try it out. So we made a dog, we made a cat, we give it some properties, we try eating some stuff and making some noises. What did I miss? Invalid use of non-static member function, animal make noise. I forgot the little confused about what is going on. And if you look, This is dog make noise. Make noise is a function. I forgot the parentheses, so I should put those in, even though it has no parameters. Try it again. Okay. Rar is making noise. Cheeto is eating the salmon. Yum. Cheddar is eating tuna. Yum. So this, the word this, you can see is highlighted in green, and it is a pointer to this animal, the one that is calling its eat function. Here I have, cat.eat and dog.eat. So this animal that is trying to eat, I can access its properties using the word this, and specifically I want to access its name, so I can say it is eating what it's eating. And that's it for our first exercise. Keeping it simple, but we're going to build on this and make it a lot bigger. So, step 2, modify the class to have two different names. I guess I kind of went ahead. The animal's species name and the animal's unique name. The species name is going to be a private variable. Make a public method to string that writes out both names. Okay, so let's make a duplicate. This will be exercise 2. So it's species name and its unique name. Species name should be a private variable. We're going to add toString to write them both out. So right now, everything is public, and we're going to make our species name private. In order to make sure we know this works, we're also going to make sure that the dogs... well, actually, let's not get ahead of ourselves. First off, species name is a private variable. We're going to need to add a public method toString that writes out both names. Okay, so toString. toString is also a bit longer, so we'll write it down here. toString. And it's going to output this name is a this species. Now, I have a bit of a pickle, which is that species is a private variable, which means I can't access it or modify it. So if I want to actually change this, this variable, I need a function for that. And what I will do is I'm going to make a setter function. So we'll call that void set species. And given a string s, it's going to set the species to be that species. And now I can go dog.setSpecies to be dog, cat.setSpecies to be cat, and instead of making some noise and things, we'll do dog.toString and cat.toString. Let's try it out. Cheeto is dog, Cheddar is a cat. Sounds good to me. Okay. So we now have divided our member attributes and functions into two different categories, private ones and public ones. The private ones cannot be directly accessed. In order to actually access the species, I can only do so using a function that belongs to the animal class. So my animal toString function can change the species. But if I try to go down here and say dog.species equals something, and I try to compile this, it will be mad, and it will say, the species is private within this context, because I'm not allowed to change it. This might be useful if, in particular, you want to limit what kinds of species you can set something to, or other sorts of ideas like that. Okay. Moving on to part 3. Modify the animal class to have getters and setters for its species names. So right now I have a setter. I don't have a getter, so I'm going to need to do that. Then we'll make a second class called habitat that represents an animal's home and include in this a private variable that represents the owner. Okay. So, continuing on to example 3. So we already have a set species. Now we need a get species. This is also going to need to be public because otherwise we're not going to be able to call the function. And it's going to return the species. So it returns a string. We'll call it get species. It does not need any parameters, and all it's going to do is return the species. You can, if you like, write this species. It is the same thing. There is no difference here because we can definitely tell which species we're talking about. There's only one to refer to. Sometimes this may be better in terms of making it less ambiguous in case you have other species defined somewhere, but either one is correct in this context. So now I have a set and get species. So now if I want to get the species, I can call that. So let's write some code down here to do so. So I can write something like one of my animals is a dog dot get species. Let's run it. Example 3, go. One of my animals is a dog. Make sense? Okay. Make a second class called habitat. It represents the animal's home. Include in this class a private variable that represents the owner, which is an animal. So I need to do this. I can't do this up above here because if I do, the computer will be confused and wonder where the heck is this animal class coming from. So I need to define animal first, and then I can define my habitat. Another thing to note, and something that we'll see later on in this course, is that you actually should almost never define two classes in the same file. This is considered bad coding practice. We're doing it here because we haven't figured out how to connect files together. But right now, since we don't, we're just going to write these two classes here. So habitat class is going to have a private variable, which is a owner, and the owner is of type animal. Okay. Now, obviously, I can't really do much with this right now, which is kind of annoying. So I probably should make some, well, I guess we'll leave it for now. I believe this should compile. I can make a habitat and nothing will really happen. Habitat H. Doesn't really do much of anything at the moment. Perhaps some of the next exercises will do something for it. But my second class here needs to be defined after the first one, and I'm just setting that it is a private animal owner. That's all. Okay, so for this next part, we're going to extend the habitat class that we just made by adding a constructor to it. Right now, there's no way to set the owner, and that's kind of annoying. So we're going to write a function, which is called a constructor, that when we build our habitat, takes a parameter, which is the owner of the habitat, and we'll write another method, which is toString, to indicate who owns it. So we're going to copy our example. And modify the habitat class by adding a constructor. Okay, so right now we just have a private owner. We're going to need a public method, which is our constructor, and the constructor must have the name habitat. And the parameter for this is a animal O, which is the owner. And this is a very short constructor, so I'll just write it here, just that the owner is O. I also need a toString method. The other one's also called toString, right? Yeah. And now to define my toString method, remember that we have two methods called toString. One belongs to animal, one now belongs to habitat. I need to make sure that I'm specifying it's the habitat's version of toString that I'm writing here. And we'll just write out this habitat belongs to do O.name. Now to make sure this works, down here we have habitat H, and we're going to use the constructor this time, and we're going to make the dog the owner of the habitat. And then we'll do H.toString. G++, example 4. What did I miss? Oh, sorry, it should be owner.name. This habitat belongs to Geo. Sounds good to me. All right, so here we have built a constructor. A constructor is going to be used in pretty much any class that you make because it makes it much, much easier to set the properties of the the classes you built here. It's very annoying to make a dog, then set its name, then set its age, then set its species, when I would rather just write a constructor to do it all at once. And that's what we have here for our habitat, although the habitat one's pretty short. If you want a bit of practice with constructors, I'd recommend actually writing your own constructor for an animal. Make it so you don't have to write 4 lines of code in order to set all these properties. Make it something you can just do in one go. That might be a good exercise just to get you more comfortable with working with classes if you're not already. Okay, next exercise. Make a food class that represents the animal's diet, including attributes like type and quantity. Modify my animal class to have a parameterized constructor that takes a food object as a parameter and initializes it. Okay, so this is going to represent things that people eat, or things that animals eat. So let's duplicate this. Here is our exercise. Okay, now, food does not necessarily rely on animals existing to be something that is there. I can just have meat. However, each animal now is going to need to have its own kind of diet. So we're going to start off making our food class. And it's going to have a type, and it's going to have a quantity. Sounds good to me. We'll keep it simple, and these will be public, because why not? Now, my animal class is going to have a parameterized constructor that takes a food object as a parameter and initializes it. So there's going to be a specific kind of food that the animal eats. Now, let's make a constructor that does a few things for us, because right now it's kind of annoying to write all this stuff in order to make an animal. So here's going to be our animal constructor. And when I say it's parameterized, what I mean is it's going to have a... I suppose we'll keep it simple for now, and we'll just put the diet in, but you might want to expand this by making the constructor add in other things such as the name, the age, the species, and so on. But for now, the animal constructor is going to take a food f, and it's going to do something. What it's going to do is it's going to set the diet. So the diet for our animal is a food type object, and it is called diet, and the diet is going to be f, whatever food we pass it. So now down here, when I make my dog animal, before I do that, I'm going to make a food salmon and my salmon dot type equals fish, and salmon dot quantity is 100. Very arbitrary number. And now what I can do is I can say, all right, animal dog equals animal, and pass it the salmon. So now I have a food object, so it represents the salmon that dogs can eat. When I make my dog, it's going to take that salmon and put that into the field representing its diet. And now to confirm that this works, instead of eating food, what we'll do is we'll just have it eat its diet. So I don't need a parameter for this anymore. And I can say it is eating the diet's type. And we'll fix that for the cat as well. Oh, did I have the... I thought I was having it eat, but I guess I wasn't. It does toString. Okay, I thought for some reason I was having the dog eat, but apparently it wasn't. So we'll have it eat down here, dog.eat. We'll cut out some of these extra outputs that we don't really need right now. And let's see what happens. Okay, what did I miss up? No declaration matches eat. Was it not called eat? Oh, it was called eat. Yeah. Oh, here I need to correct this so that eat doesn't have a parameter. So let's fix that. Try it again. What else did I mess up? No matching function call to animal. Okay, so here when I make my cat, it also needs to take a salmon diet. Again, habitat. Okay, so the next thing that it's complaining about here is that I don't have a constructor that takes no parameters, which perhaps I should do. So just to confirm that that is okay, we'll just write a constructor that takes nothing and does nothing. I think that should get rid of this issue. Okay. And this might just be a thing where the computer wants to be able to make an animal with no properties, which is hopefully not necessary. But in this case, we'll make sure that there is at least some code written here to tell the computer, hey, it's okay to make an animal that doesn't have a diet. We'll probably never do so, but just so that the thing compiles, we'll let it go. So now that I've run it, what happens if I execute this? Cheeto is eating fish, yum. I'm calling dog.eat. Dog.eat says this name is eating, and it's this type of diet. And we'll actually add in the quantity. Diet.quantity as well. And a space. Just to use all of the properties we have available to us. There we go. Cheeto is eating 100 fish. Yum. Because that's what we said the type was the salmon. I guess this should be the other way around. Probably if you want to make this proper, we should do food, fish, salmon, fish. Just to be a little more reflective of, I guess, how you would actually use this. The specific type of fish is salmon, and it's 100 of it. But maybe there's a second fish, and the second fish is a tuna, and so on. Now this should say Cheeto's eating 100 salmon. Okay. All right. Number 6, extend the animal class by adding a method eat, which takes food as a parameter, and adjusts the animal's hunger level. Overload the eat method to take an additional parameter representing the amount of food consumed. Okay, so we're going to need to modify this quite a bit because we already made an eat method. It doesn't do exactly what we're being asked to do. So let's duplicate this. Okay, I'm going to add a method eat that takes food as a parameter. And it's going to take a food object and adjust the animal's hunger level. So we already have an eat method that takes nothing. We actually can overload this to take a few different varieties. So first we're going to do another one, which is void eat that takes a food. And we'll make another one, which is void eat that takes a food and a quantity. Okay, let's do these one at a time. So we have our first one, which is the one that we did from before. Now we'll do another one, which has the same name, but it has a parameter food. And now our food already has a quantity, and so we're going to need to adjust the animal's hunger levels. So let's start with a hunger level. Int hunger. And when we run our initializations, let's start with our hunger being 100, just because. Hunger is 100, and we'll do that over here too. Hunger is 100. So now all of our animals start with a hunger of 100, and we're going to see if we can reduce that down. When I eat this food, we're actually going to say we're eating this food, and we'll also reduce the hunger. So this hunger minus equals the food's quantity. And for the other version of eat, where it gives us a food and a quantity, we're going to reduce it by the quantity that's given instead of the quantity that's associated with the food. So let me show how these all differ. So the first version of dog.eat just says, I eat my diet, yum, great. So hunger level dog.hunger. And let's set our salmon quantity to be 10 so we can actually see some things working as we want. After we do dog.eat, we're then going to do dog.eat and pass it a food object. So let's pass it, in this case, one of the fish. So here it says, actually, let's make a different food. Let's give him some I don't know, peanut butter. Food PB. PB.type equals peanut butter. PB.quantity equals 20. Now we can do dog.eat the peanut butter and print out its hunger level. Then we'll do it again, except this time we're going to eat the peanut butter, except we're going to eat 60 units of peanut butter. And we'll see how the hunger level changes every time. Okay. Compile. Run. So we start out by eating 10 salmon, but because that's just the diet, and in fact, we may actually want to make it a little clearer by saying we're not eating a quantity of the salmon. We're actually just going to say just is eating salmon. We'll do that for the sake of making this a little more clear of an example. So Cheeto eats salmon, great. However, his hunger level is at 100. Then he can eat 20 peanut butter, and his hunger level actually goes down to 80. Then it says he's eating 20 peanut butter, and it goes down to 20. That's not quite right. He ate 60 peanut butter, which reduced his hunger level correctly, but it displayed the wrong error message and the wrong feedback message. And the reason for that is because here I said it's eating the quantity associated with the food, not the quantity associated with the parameter of 60 that I passed. So I'm going to remove food dot from here. And now when I compile and run, it says I'm eating 60 peanut butter, dropping my hunger level to 20. Great. We're almost there. Only 2 more exercises to go. Make a zoo class that contains an array of up to 30 animal objects representing different animals in the zoo. In the zoo class, add methods to add an animal to the zoo and display information about all the animals in the zoo. Okay. So, duplicate. All right. Zoo class. Since our zoo class is going to contain animals, it will need to be written after I write about animals themselves. It doesn't really matter how I write it in representation to a habitat because they don't seem to be associated, but I'll put it down here before the main function after habitat. So my class is called zoo. It can have a, so what did it say it needs to have? This is display information. So we'll keep the member variables private because it's good practice. And it's going to have an animal array of 30 animals, up to 30. Some of them will be empty at the beginning. Now I need a method to add an animal to the zoo. Add animal, and it should take an animal as a parameter. Also, I should keep track of how many there are. So int count. It starts at 0. I guess to make it sure it starts at 0, we'll write a constructor for that. So the zoo constructor is just going to make count be 0. When we add an animal, all we do is set animals count to be that animal, and then our count goes up. So now I have a class that contains an array of animals. Every time I want to add an animal to it, it just goes into the array, and then I go up. I can't remove anybody from the zoo, unfortunately. And if I want to display info, we'll write a function for that. So it belongs to zoo. It's called display info, and it's going to have a loop. I is less than the count of the zoo. And we're going to go to the zoo, go to its animals. And now each animal, so the ith animal has a method called toString, and we'll call it. And we'll do that for every animal. And to make sure this works, I need to make a zoo. We'll comment out the hunger stuff that we were doing here. We'll make a zoo called Z. Z.add_animal dog. And cat. And then we'll add another dog just because. And then we'll do Z.displayInfo and see what happens. Load this up. Compile. Run. All right. We got Cheeto and Cheddar and Cheeto because I added a dog, a cat, and a dog. So I have a class that contains an array of other objects. I need to keep track of how many there are, otherwise I'm not going to be able to work with it very easily. When I initialize my zoo, I have none. But every time I add an animal, I increase how many there are. So I'm always keeping track of the number of animals in the zoo. And my display info is just going to use that count number to keep track of how many animals are there and print out each one. To print out the data from each one, I'm using its toString method, which I wrote for animal over here. So this animal is the species. And I add a dog, a cat, another dog, and then display that info. And there we go. I believe that's everything it said. All right, last one. Modify my animal class to include a static variable that keeps track of the total number of animal instances created, i.e. the total population. Include a method in the animal class to display the total number of animal instances. Okay. So, duplicate. Number 8. All right, so inside of animal, I'm going to have a public integer called population. But this is not just going to be a regular integer, it's going to be a static integer, population, which starts out as 0. And any time that you make a new animal and give it however amount of food it has, we're going to increase the population by 1. And the reason for doing it this way is that this means that every animal has a reference to how big the population is. But every time I make a new animal, it doesn't reset this number to 0. It actually is going to keep going up. So over down below, I make an animal here, and I make an animal here, so the population should be 2. Let's double check that. Dog.population. And comment out this other stuff. Compile, example 8. Oh, I forgot to comment out the display info, and also it seems very unhappy about an in-class initialization of a non-constant static member. So I think it may have to be a constant static. Let's see if it's okay with that. Increment of read-only variable. That's not ideal. What did I mess up here? Forbids an in-class initialization. I think it might be the case that this needs to go elsewhere. Let me double check. Oh, I think I'm not supposed to set this as 0 to start. Okay, now it's a little spooked. Oh, I think what it is, okay, so it's been a while since I've used a static variable in C++. So I need to declare here, this is a static number, meaning that the population does not vary between each of the animals that are there. So that when I access, dog.population and I access cat.population, these should be the same thing. They should both be 2, because I have a dog and a cat. Now to make sure that this is actually set to be 0, because right now it's just going up, but I haven't initialized it to be anything, I'm going to write code here that says int animal population equals 0. I think I just do it like that. Okay. And there we go, there's my 2. So after declaring my class and all the properties that it has, I also need to set the initial population to be 0. Now that the initial population of all the animals is 0, anytime I create a new animal, it increases how many are there by 1. Include a method in the animal class to display the total number of animal instances. So right now I'm just directly accessing the population, which is not ideal. So let's do a method called, it says to display, right? Display the total number, yeah. Print population. The total population is population. And now over here, I can do dog.print population and cat.print population, and they will be the same. Oh, what did I mess up? It's not called print population. Actually, why is it angry? Let me clear this and compile that again. Oh, right, it's it's not supposed to print anything. I just call it print population. There we go. Sometimes you get a lot of big spooky errors for what's just 2 lines of code. Total population is 2. And this population is tracked even though Cheeto was created first and wasn't really aware that Cheddar was created after. And so this is maybe the first example of classes sort of being linked together with one another. And in this case, we have what's called a static, meaning unchanging variable that is going to be consistent throughout any animal that I'm working with. If I decide I have some other function, maybe I write like repopulate and I add to the population, this number is going to be the same value for every animal that I have, regardless of when I made that animal or which one is being modified. So it's worth understanding how these static variables work because you will see a lot of them in real life code. And it's good to know sort of how they differ from normal variables, where if I change, Cheeto's age, for instance, Cheddar doesn't know that I've changed Cheeto's age. But if I modify this population, all animals are aware of that because it is static. So I think that wraps up everything I want to cover with these examples. Hopefully this was useful. Let me know what you think about it, and I will see you in class. Bye-bye.